The fundamental principle behind any occupational health and safety program should be the control of hazards. Any occupational health and safety program that does not have the control of hazards at its core is doomed to produce poor results. Hazards are present in all workplaces and can have different effects on different people. Short and long-term illness, injuries, and even death. Hazards also have the potential to cause damage to plant and equipment. Lost productivity, increased costs, and most importantly, human suffering are three good reasons why it is vitally important to control all hazards in the workplace. Let's take a look at just some of these hazards. So, how do we control hazards? We must first recognise they indeed exist. Next, evaluate the risk each hazard presents. And then, adopt a strategy of control measures to eliminate or reduce the risks. More simply, this could be expressed as the recognition, evaluation, and control of hazards. As we have already said, recognition of a hazard is the first step in hazard removal or control in the workplace. In many cases, hazards are easily identified. Untidy work areas, inappropriate or damaged tools, incorrect manual handling techniques, and so on are all fairly obvious. Identifying, for example, a dangerous fume from a production process can be a lot more difficult. Likewise, the consequences of a pipe bursting or a chemical spill are not easily recognised. In these less obvious situations, we may need to know some of the following. Information about the chemistry and toxicity of raw materials, products and byproducts. Technological information about a process. Details about the behaviour of any possible airborne contaminants. An understanding of the routes of entry of contaminants into the body and possible effects of these contaminants. The recognition of hazards is not as simple as may first appear. Experience and information are often the most important ingredients. Once we have identified or recognised a hazard, there has to be some evaluation of the risk presented. Is the risk acceptable? Do we need to control it? In many cases, we can make an objective evaluation based on experience. In other cases, we may need to take scientific measurements to evaluate the extent of the risk. Outside consultants and experts may also be required in certain situations. If the evaluation indicates a need for control, there are a number of options available, and in many cases, a combination of control measures will be required to reduce the risk to an acceptable level. The ultimate control measure is to eliminate the substance, process, or activity presenting the hazard altogether. Examples of the elimination technique could include removing a fire hazard by using non-combustible materials instead of combustibles, using a pneumatic or a hydraulic system instead of an electrical system is another example of eliminating fire hazard. Using a supplier to handle a particular process that may be more suited to and less hazardous at their location. removing sharp edges and corners from plant and equipment, eliminating protruding materials and objects, eliminating a manual handling task by using a mechanical lifting device. There are obviously numerous other examples, but what if we can't eliminate a particular hazard? Our next best option becomes substitution. Can we substitute a process, chemical, or activity for a less hazardous one? When looking at substitution options, we should ask a series of can we type questions. For example, can we have a toxic substance supplied in a different form which will be less hazardous? For example, replace a liquid with a powder. Can we have a toxic substance supplied at a lower concentration and still effectively perform the task? Can we reduce the handling of a material by having it delivered to a different location? Can we divide a load to make it easier to handle? Can we reduce the level of airborne contaminants? For example, by replacing a spraying process with a dipping process. Tackling hazards by elimination and substitution can be very effective and often at little or no added expense. Unfortunately, elimination and substitution are only practical and fully effective in dealing with some hazardous situations. We must frequently employ administrative and engineering control measures. Administrative controls involve laying down policies and managing workplace procedures. Examples would be establishing procedures for the ongoing maintenance of plant and equipment, monitoring of contaminant levels, organising hazardous operations when relatively small numbers of people are present, commonly between shifts or after normal working hours. Rotation of workers to reduce exposure to a particular hazard. These are all examples of administrative controls that can contribute significantly to hazard control. Engineering controls are many and varied. The general design of the workplace, plant and equipment. The installation of additional lighting to provide adequate illumination. The use of automation and mechanical devices. These are examples of engineering controls that often come quickly to mind. Safe welding practice is representative of a group of engineering control measures commonly referred to as isolation. Hazardous light emissions and sparks are isolated from other people and work areas by the use of screens. Storage of chemicals is another example of isolation strategy. Different amounts of different chemicals stored in different conditions and locations. Noise is often addressed by the utilisation of the isolation principle. However, this time in a different form, enclosure. By enclosing the source of the noise, or alternatively, enclosing the operator, we can effectively isolate the person from the noise. The installation of machine guards, interlocks and warning devices are all further examples of the isolation principle. This is an example of another strategy, containment. Here, with the use of a local exhaust system, we are effectively removing contaminants before they can enter the atmosphere. Simply, we are containing the hazard at its source. The use of a technique best described as limitation is the last of the major engineering control groups. Here, the purpose is to limit the effect of a potential hazard to ensure no injury or damage will result. For example, to maintain a system's pressure to a safe limit, safety valves may be installed. The potential of an electrical hazard may be reduced by using low voltage and low amperage power or batteries instead of the normal power supply. Preventing or limiting the potential of spills may be achieved by the installation of an overflow system. Personal protective equipment is positioned as the last option in controlling hazards. That is, as a control measure, its role is effective only when all other options are either unsatisfactory or not practical. There are indeed two situations where the use of personal protective equipment is vital in hazard control. First, when carrying out normally hazardous operations such as welding, spraying, or working in a confined space. And second, in emergencies or when conducting investigations where the levels of hazards are unknown. We should not confuse the role of personal protective equipment as a control measure with its more widespread role as a precaution, a last line of defence should an accident occur. Well, as we have seen, there are numerous ways available to us to control hazards. Let's just briefly recap the whole process. First, we must recognise that a hazard exists. Then, we must make an objective or scientific evaluation as to whether or not we need to control the risk presented. And finally, if necessary, we must implement a control strategy. Control measures start with elimination, which is the ultimate control, through to substitution, administrative controls, engineering controls, and finally the option of wearing protective equipment. With the engineering controls, we break this down into 4 groups: isolation, enclosure, containment, and limitation. The process may be complicated in many cases. However, the message is simple. With a system in place for the recognition, evaluation, and control of hazards, we can effectively minimise the risks presented by all hazards. Fewer illnesses and injuries, increased productivity, reduced accident costs, and an increase in safety awareness are some direct results of a hazard control program. Recognition, evaluation, and control is really such a fundamental safety concept that it should be understood and practiced by everybody in the workplace.